Data science is much more broad. Our world is full. In fact, we're saturated with data. We're consumers, we're producers of data.
Eventually touches families toward improving their quality of life, improving access. I'm on the way, back end of it. But
take in data by ingesting it, cleaning it, manipulating it, summarizing it, analyzing it, and modeling it, incorporating programming languages such as Python, RStudio, SQL, Tableau, any of these software that students are using right now.
Picture a pyramid, solid, structured with several distinct layers. At the very foundation lies the bedrock of healthcare analytics, data acquisition. This is where our journey begins, the starting line, the point at which raw information begins its transformation into powerful insights. Imagine collecting ingredients for a complex recipe. In healthcare, those ingredients are vast: data from electronic medical records, streams from wearable devices tracking vital signs, and insights gathered from clinical trials. This is the backbone of healthcare data science, collecting the right information at the right time from the right source. But who ensures that this ocean of data is ready for its transformation? Enter the unsung heroes of data science, the data architects. Picture them as chefs in a busy kitchen, ensuring each ingredient is perfect before it hits the pan. They're the ones managing everything, from the old-school warehousing solutions that have stood the test of time to cutting-edge cloud platforms that allow data to flow seamlessly. But here's the kicker: accuracy is only half the battle. The other half? Security. We're talking advanced encryption, strict access controls, and of course, compliance with HIPAA regulations. It's not just about storing data, it's about safeguarding it from prying eyes. Whether we're using legacy systems or the latest cloud-based tech, our methods are all about creating a fortress around the data we collect. This meticulous approach to data acquisition is what lays the foundation for everything that follows. Get this right, and everything else falls into place. It's the first, crucial step in turning raw data into something meaningful, setting the stage for the healthcare breakthroughs that follows. Moving up from the foundation, we arrive at the next critical layer: data preparation. It's like prepping ingredients before you start cooking, essential for the final dish to be perfect. Data preparation is about refining the raw ingredients. We're dealing with missing values, removing duplicates, and transforming the data into a usable format. Imagine every record being checked for accuracy and consistency, ensuring everything is ready for analysis. Sometimes this means converting binary values like 1 and 0 for mathematical models. Other times we create entirely new metrics and dimensions that give us deeper insights. We also use techniques to summarize, group, and clean the data, making it primed for extracting valuable insights. In the past, data marts were our go-to for storing this prepared data. But now we leverage cloud-based solutions like tenant layers and data lakes. These advancements allow us to scale our data management effortlessly, ensuring robust and secure storage for the vast amounts of data we handle. Effective data preparation lays the groundwork for everything that follows. By turning raw data into a refined, organized dataset, we ensure that it's ready for deeper analysis and insight extraction, setting the stage for the breakthroughs ahead. Now we move to the heart of the process: information extraction. This is where the magic happens. The data collected and prepared is now turned into actionable insights. In this phase, analysts and data scientists dig deep to uncover relationships within the data. The goal? To discover the function y equal to f of x, where y is the outcome we want to predict, and x represents the independent variables that influence it. It's a mathematical puzzle. Solving this unlocks valuable insights. To extract meaningful insights, we experiment with metrics like mean, mode, and variance, which help us grasp the underlying structure of the data. By identifying patterns and trends, such as changes in averages over time or spotting unusual variations, we gain a clearer understanding of the data. These insights from analytics guide us in improving patient care and optimizing healthcare systems. For more complex predictions, we turn to advanced machine learning algorithms. Take Random Forests, for example. This algorithm builds multiple decision trees and merges them to get a more accurate and stable prediction. It's particularly useful when we are dealing with noisy data, which is common in healthcare. Another favorite? Support vector machines or SVMs. These help us classify data points by drawing the best possible boundary between different groups. Why use it? Because SVMs can handle large, complex data sets and are powerful when precision is key, like diagnosing diseases from complex clinical data. And sometimes, when we don't know what structure the data holds, we use unsupervised learning methods like clustering. This method groups data points that are similar without predefined labels, allowing the data to tell its own story. Deep learning adds another layer of sophistication. Convolutional neural networks, or CNNs, are our go-to when working with image data. In healthcare, this could mean analyzing medical scans or X-rays to detect patterns that the human eye might miss. CNNs excel at identifying patterns in visual data, making them indispensable for radiology. On the other hand, recurrent neural networks, or RNNs, are ideal for sequential data, like time series data from patient monitors. These networks retain information from previous steps in the sequence, allowing them to understand patterns over time, which is essential for predicting patient outcomes or monitoring disease progression. Natural language processing, or NLP, is another powerful tool in our toolkit. In healthcare, so much of the valuable data is hidden in unstructured text. Think doctor's notes, patient records, and research papers. With models like BERT and GPT, we can analyze this data to uncover important trends, identify potential risks, and provide deeper insights that are often overlooked in numerical data alone. But all this data extraction and analysis would be meaningless without effective communication. That's where data visualization comes in. Tools like Matplotlib, Seaborn, Plotly, and Tableau help us transform complex findings into simple, interactive dashboards. These tools allow decision-makers who may not have technical backgrounds to clearly understand the insights and make informed choices that improve patient outcomes. Information extraction is more than just analyzing numbers. It's about uncovering the stories hidden in the data, stories that have the power to revolutionize healthcare. Whether it's improving diagnoses, optimizing workflows, or predicting patient outcomes, the insights gained here form the backbone of actionable decisions. At this phase, data meets collaboration, and the insights gathered are transformed into impactful real-world decisions. But this isn't just about delivering data, it's about translating that data into action. Here, collaboration is crucial. Data scientists work alongside healthcare professionals, hospital administrators, and decision-makers to ensure that insights lead to actions. Every dataset is tailored to address the specific pain points faced by these stakeholders. It's about bridging the gap between the data world and the real world. Consultative analytics is more than just interpreting data. It's about applying those insights in a way that directly impacts patient care, reduces costs, and optimizes operational efficiency. Through interactive dashboards, healthcare teams can visualize performance trends, identify bottlenecks, and make informed decisions quickly. Consider diagnostic toolkits that allow for dynamic exploration. Leaders can drill down to granular levels, see real-time alerts, and even simulate different strategies. Imagine a hospital optimizing its resource allocation in real time based on staffing data, patient inflows, or medication supply levels. This is consultative analytics in action. Consultative analytics ensures that insights are not just understood but acted upon, creating a direct line between data-driven insights and tangible improvements in healthcare delivery. Now we reach the pinnacle of the pyramid, business strategy. Here, data becomes more than just a tool. It becomes the very foundation of decision-making, guiding long-term strategy and revolutionizing how healthcare organizations operate. At this level, the insights derived from data flow into the strategic conversations that shape the future of healthcare organizations. It's not about making small adjustments. It's about identifying transformative opportunities for growth, efficiency, and patient care. Through advanced simulations and what-if scenarios, decision-makers can predict the outcomes of their strategic choices before they're even implemented. By integrating predictive modeling and trend analysis, leaders can see which initiatives will reduce costs, improve patient outcomes, or enhance operational efficiency. For example, hospitals can use these insights to predict patient inflows, allowing them to manage staffing more effectively. Insurers can optimize costs by forecasting claim patterns. This is where the value of data becomes undeniable, turning strategy into action and action into measurable success. In today's competitive and ever-changing healthcare landscape, data-driven strategies enable organizations to innovate and stay ahead of the curve. Whether it's improving the quality of care, reducing administrative burdens, or driving research breakthroughs, data is the key to unlocking these opportunities. The real power of business strategy comes from integrating short-term operational data with long-term goals. Leaders can monitor immediate trends while staying aligned with the overarching mission of healthcare organizations to provide the best possible care, efficiently and effectively. Incorporating data into every level of strategy is not just a trend, it's the blueprint for future healthcare success. With data-driven insights, organizations can transform their strategies, enhance patient outcomes, and build a more sustainable and impactful future.
As we wrap up, let's recap the key takeaways from today's journey through the information extraction framework. It all begins with collecting high-quality data from reliable sources, whether from electronic medical records, wearables, or clinical trials. Next, data preparation ensures we clean and organize this raw information for accurate analysis. Information extraction is where the magic happens, turning that data into insights using advanced machine learning models. Through consultative analytics, we turn those insights into real-world actions, collaborating with healthcare professionals to solve specific challenges. Finally, business strategy integrates data-driven insights into long-term decisions that enhance healthcare efficiency and patient care. Thank you for joining us on this insightful journey through data science in healthcare. If you found value in this content, be sure to like, share, and subscribe for more in-depth analysis and insights. Have a topic you'd like us to explore? Let us know in the comments below. We'll see you next time on Blumenthal.